We're looking at the lesson on applications of inequalities. And I'm going to go through number 2. I'm going to do parts A, B, and C. After this, I'm just going to ask you to do part A. For numbers 3, 4, 5, 6, 7, for the rest of the lesson, I only need you to do part A. And I'll kind of show you what I mean. Okay, part A, the first part, is really all about translating from English into algebra. And that is a challenge. Now that takes a lot of practice. It's important because nobody just walks up to you and says, 5x plus 2 equals 7. What is x? That would be weird. You'd turn around and walk away. But this is this is a situation that actually could happen. Jean babysits for $6 per hour. She also works as a reading tutor for $10 an hour. And this week, her goal is to make at least $75. One thing you'll notice is I haven't talked about the 20. I'm going to come back to that. I'm going to keep dollars with dollars with dollars. So in any of these problems, if they start talking about money, keep money with money. And that'll make things easier for you. Okay, so I'm going to translate the fact that Jean babysits for $6 an hour, and she also is a reading tutor for $10 an hour. I'm going to move over to a document camera here quick. There we go. And it's about right. There we go. So if I'm going to write that down, one way we can do that, or the way I'm going to do it anyways, is I'm going to say that $6 an hour for babysitting, I say is 6 times B. So she gets $6 for every hour of babysitting. 5 hours of babysitting, 5 times 6, $30. And reading tutor, I'm going to use T for tutor, is 10 times T. However many hours of tutoring, 2 hours of tutoring, 2 times 10, that's $20 for tutoring. And together, combined, her babysitting money plus her tutoring money, she needs to make at least $75. If you were in the room, I'd ask you some follow-up questions with that, but at least is going to mean that she could earn more than $75. Whatever this dollar amount totals could be more than $75. I'm sure she'd be very happy. Or it could be exactly $75. So in general, at least, I know my hand is in the way here, at least is going to be greater than or equal to. If you see that term, something, needs to make at least this much money or needs to move at least this far. We're talking greater than or equal to. The other side of that, at most. At most, you can have at most 3 people over for your birthday, whatever. You need to stand, at most is going to be less than or equal to. So that's at most. Okay. There was another part to the problem, though. We got the money figured out then. She is only allowed to work, looking right here now, she's only allowed to work 20 hours per week total. So between her babysitting hours and her tutoring hours, she's only allowed to work 20 hours a week. That's different from money. This next line here, the second inequality, can be a bit challenging at first because it's almost too obvious. There's no other numbers to work with. But what we would say is that her number of hours of babysitting, whatever those hours are, and her number of hours of tutoring, however many hours she has for tutoring, together, the babysitting hours plus the tutoring hours, I lost it here. She's only allowed to work 20 hours a week, which means that she can't work more than 20 hours a week. She'd have to work less than 20 hours a week. Or exactly, she's only allowed to work 20 hours a week. Less than that is fine, but can't work more than 20 hours that week. This is what's called a system of linear equations. And what I would want you to do is I'd want you to type this into the box. That's what I want you to answer for all the rest of these. This is part A. This is what I need you to be able to practice doing, is translating English into a math situation. Greater than or equal to, how do you type that? On the keyboard, most keyboards anyways don't have a greater than or equal to sign. So in computer programming and in what we're going to do, you would typically write greater than equal to. So if you want to write greater than or equal to in the box, you write the greater than sign and the equal to sign. Less than or equal to is less than equal to. So that's what you'll type in the box for greater than or equal to, less than or equal to. That's part A. I'm going to do part B and C on this problem, but you don't need to do part B and C for the rest of them. Part B is asking us to graph this. And outside of math class, in the real world, this happens often, where we need to have some inequalities with some different variables. A lot of people will buy a program or pay somebody to do the graphing for them. So I'm going to do that for you right now. I'm going to count by fives here. It doesn't really matter which one is our X and which one's our Y. I'm going to go ahead and make this my tutoring. And this is going to be my babysitting. Right there. So the X-axis is my babysitting. Tutoring is my Y-axis. I'm going to graph the number of hours first. So she needs to work at most 20 hours. She's only allowed to work 20 hours a week or less. There's an infinite number of combinations of hours that are less than 20. It could be 5 and 5, could be 5 and 10, it could be 12 and 7, it could be, I guess not 12, 7 and 12. There's lots of different variations on combinations. Anything in this shaded region down here will work for the number of hours. Now I'm going to graph the money. I need to think a little bit harder for this. And it's going to be there. So there's your $75. And she's okay making more than $75. So I would say any combination of money, up to a bajillion. She's probably fine making that. That's part B. Part B is creating the graph from these two inequalities. Part C, I would say, is almost the most important. Part A and C are both really important. Being able to translate into algebra and then being able to interpret, to understand what's going on in the graph is the other big important part. Calculators can do part B. There's a lot of online graphing calculators. You type this in, it poof, gives you the graph. Part C, the understanding, interpreting is important. What they're asking is, what region of this graph works for both of these at the same time? This area down here, any combination down here, is less than 20 hours, but it's not enough money. This region up here, let's say this point right there, that's plenty of money, but it's way too many hours. So the region that works for both the money and the hours at the same time is this region in the middle. This is like the sweet spot. And in engineering and in other areas, we call this a tolerance, where anything in between these two lines is going to work for both of those inequalities. In business, this would be like we've got expenses. We have to buy, pay for electricity, pay for the property, pay employees, but we also have a profit. And we want to make a certain amount of money and still pay people. And we're trying to kind of narrow in on that sweet spot of what works for both of our inequalities. So that's it. That's part C. That's the idea here. You cannot solve this inequality. It is impossible to solve because there's an infinite number of answers. And you just can't solve an infinite number of answers. It doesn't work. So we graph it to represent all the different possibilities. All infinite number of answers are in this graph. Somewhere in this checkered region is the solution. All right, that's my spiel there. Part A, that's what I need you to do for all the other fill in the blank boxes, is typing the inequalities, typing the system of linear inequalities. If you have questions, if you want to know more, or if you want to see more examples, let me know.